Welcome to today's episode of the Daily AI Brief. Today, we're diving into some groundbreaking AI developments, from Google's efforts to make technology more accessible to advances in AI driven software. We've got fascinating news in store, including insights into new AI frameworks enhancing advertising, innovations in coding, image analysis, and more. So let's explore these intriguing advancements. Google Research has recently launched its natively adaptive interfaces, NAI, marking a significant milestone in addressing accessibility gaps that impact around 16% of the global population. The goal is to implement personalized, real-time adaptable interfaces to assist individuals with disabilities, thus enhancing their interactions with technology. NA integrates advanced multimodal AI tools designed to provide real-time feedback. The use of context-aware AI is pivotal in refining these interactions, making them more intuitive and user-centric. One of the standout components of NAI is Street Reader AI. This technology specifically targets accessibility within Google Street View for visually impaired users by generating real-time AI descriptions. These descriptions can be accessed via voice commands or keyboard shortcuts, allowing for a seamless navigation experience. Street Reader AI is currently being tested with blind and low vision users. The preliminary results are promising, indicating improvements in navigating points of interest and planning routes more efficiently. Despite these advancements, challenges remain regarding the effectiveness of these interfaces across varied global platforms. The extent of Street View coverage might vary, affecting the uniformity of the experience offered by this technology. For those interested in exploring the technical aspects of NAI, resources like the Google Research blog /research.google/blog/how AI agents can redefine universal design to increase accessibility provide a comprehensive overview of the features and potential applications of these interfaces. Engaging with the Street Reader AI project can also be insightful, particularly when tested alongside individuals experiencing visual challenges, to better understand the real-time, context-aware navigation capabilities. Ultimately, Google's NAI initiative represents a pivotal shift towards inclusive technology. It strives to redefine how digital interfaces are designed and utilized, potentially influencing market strategies and leading to broader implementations of adaptive technologies. While the journey towards universal accessibility is ongoing, NAI sets a robust foundation for future innovations in accessible tech. Apple has released Xcode 26.3, integrating AI coding agents like Anthropic's Claude and OpenAI's Codex directly into the development environment. This move represents a shift towards greater automation in coding by enabling these AI agents to autonomously write, modify, and test code, as well as perform efficiency searches through Apple's extensive developer documentation. The integration uses the Model Context Protocol, MCP, to connect these AI agents to Xcode's functionalities, allowing them to perform tasks beyond mere code suggestions. This development marks a significant progression from previous iterations, which limited AI involvement to coding suggestions without autonomous execution capabilities. As a result, there is a notable potential to streamline workflows and enhance productivity. One key technical advantage is that the AI agents are equipped with advanced error identification features, enabling them to catch bugs that might be missed by human eyes. They also offer smart querying of Apple's developer resources, which can significantly reduce time spent looking for information manually. This efficiency gain is particularly important when considering large-scale projects where documentation can be vast and complex. However, while this update has the potential to revolutionize how developers work, challenges such as the reliability of AI agents in diverse coding environments and the learning curve for developers adapting to these tools remain. Additionally, the varying capabilities of AI agents in different programming contexts could affect their performance. Developers interested in leveraging these new capabilities should update to Xcode 26.3 and watch the introductory video on agentic coding provided by Apple here at tweet.ute.com ov6mem.c81ky and source OpenA. Additional insights can be gained from reviewing Apple's documentation on the release. The inclusion of these AI agents might redefine developer workflows by automating tedious tasks like code testing and bug fixing. potentially allowing developers to focus more on creative aspects of software design. Yet the trade-off includes possible over-reliance on AI, which could impact long-term coding skills if developers become too dependent on these tools. The takeaway here is that Xcode 26.3 represents a bold step forward in automating software development, potentially setting a new standard for integrated development environments. As these AI capabilities become mainstream, the landscape of coding could be significantly altered, prompting shifts in project management and development strategies across the industry. The ongoing evolution of these tools will be crucial to watch, as they may lead to further breakthroughs in how we conceive and realize software projects. NVIDIA has introduced Vibe Tensor, a cutting-edge software stack for deep learning, entirely generated by AI agents. This innovation marks a significant leap in AI-assisted coding, simplifying the creation of complex deep learning systems. However, while its impressive C++20 core and compatibility with Python and Node.js interfaces promise flexibility and modern framework support, there is much to consider regarding its readiness compared to established frameworks like PyTorch. Vibe Tensor is a substantial creation, consisting of approximately 47,000 lines of code. This intricate codebase is the result of NVIDIA's fourth-generation AI agents efforts. The core features include a reverse-mode autograd engine, critical for efficient machine learning model training, and a schema-light dispatcher that optimizes operation management. Further enhancing its capabilities, the software employs a stable CABI, which facilitates the integration of dynamically loaded operator plugins, potentially increasing versatility. One of the system's specific innovations lies in its architecture, particularly with the custom CUDA stream and the innovative Tensor subsystem known as Fabric. Fabric serves as an explicit multi-device abstraction layer, allowing for seamless management of complex multi-device configurations, crucial for high-performance computing tasks. Despite these advancements, performance benchmarks indicate that Vibe Tensor operates between 1.7 to 6.2 times slower than PyTorch, especially in scenarios where PyTorch's well-optimized operations excel. For developers eager to explore Vibe Tensor, NVIDIA provides access to its GitHub repository /github.com/NVIDIA/VibeTensor, where the source code and comprehensive documentation are available. By running its provided benchmarks, developers can directly compare Vibe Tensor's performance against existing frameworks like PyTorch, gaining insights into its usability and potential for real-world applications. While Vibe Tensor showcases a promising stride towards automated software engineering, it's crucial to scrutinize its slower performance metrics compared to leading frameworks when considering deployment in production environments. The development philosophy underlying Vibe Tensor, leveraging AI for the complete software generation process, sparks excitement yet raises questions about long-term maintainability and the cohesiveness of its AI-generated components. This issue resonates with concerns over the Frankenstein effect, where independently developed features may not integrate optimally. In conclusion, Vibe Tensor represents a significant development in AI-generated software. Its launch not only highlights the possibilities within automated software engineering, but also sets the stage for broader exploration into AI-assisted methodologies. Developers now face the task of balancing innovation with performance and reliability as they consider integrating Vibe Tensor into their deep learning projects. The interest it generates will likely encourage further advancements and potentially inspire enhancements in other frameworks, marking an evolutionary step in software development paradigms. Google's latest advancement, the Gemini 3 Flash, integrates agentic vision, redefining image analysis with a think, act, observe loop. This iterative process significantly enhances image comprehension, marking a departure from traditional models that process images in a single sweep. Agentic vision allows multi-step analysis, elevating accuracy and detail through real-time Python code execution for tasks like cropping and annotating. This innovative approach has shown a 37% improvement in multi-step visual question answering tasks and a 28% increase in detecting subtle defects compared to previous models. The think phase of agentic vision involves analyzing the user's input to formulate a robust plan of action. The act phase executes the planned manipulation of images, such as rotating or cropping, via generated Python code. The observe phase then feeds the transformed images back into the model, allowing for continuous improvement. This dynamic interaction harnesses advanced visual reasoning capabilities, offering more precise outcomes compared to traditional approaches. While these metrics highlight its impressive capabilities, challenges in generalization across diverse tasks and computational overhead are noted. These potential trade-offs include increased processing demands and varying effectiveness across different image types and tasks. Consequently, developers must be vigilant about the conditions under which the model is deployed to ensure optimal performance. Gemini 3 Flash's integration with Google AI Studio and Vertex AI facilitates these advancements by providing seamless tooling for developers. This integration encourages experimentation and application development through resources like GitHub repositories, where extensive documentation and sample datasets help developers navigate the system efficiently. Practical impacts of such technology could fundamentally transform sectors such as medical diagnostics, where precision and accurate image analysis are crucial. By enhancing the detail and interpretative capabilities in image-based tasks, agentic vision could lead to improved diagnostic outcomes and more efficient workflows in radiology and pathology. In summary, agentic vision in Gemini 3 Flash propels AI image analysis into a new era of detail and accuracy, setting a higher standard for performance while posing questions about the balance between computational cost and analytical capability. NVIDIA has unveiled Kimi K2.5, a dynamic multimodal vision language model, VLM, crafted to revolutionize AI workflows. With a groundbreaking 1 trillion parameters and a substantial context length support of 256,000 tokens, Kimi K2.5 is set to redefine the way AI processes text, images, and videos cohesively. This powerful open-source model, developed by Moonshot AI, incorporates an advanced mixture of experts, MOE architecture, enhancing its processing efficiency. Unlike traditional models, which operate with a single agent approach, Kimi K2.5 leverages the innovative agent swarm paradigm. This enables the coordination of up to 100 subagents, facilitating parallel workflows through up to 1,500 simultaneous tool calls. Such capabilities dramatically speed up execution times, potentially making tasks up to 4.5 times faster than single-agent setups. Kimi K2.5's capabilities emphasize the importance of efficient handling of intricate multimodal tasks, offering significant advantages for applications requiring detailed and complex reasoning. However, these capabilities do come with certain trade-offs. The demands for computational resources are considerable, particularly for processing extensive context lengths. Moreover, the model's performance might vary across different deployment environments and tasks, highlighting the challenge of generalizing its function in varied real-world settings. For developers and enterprises interested in utilizing Kimi K2.5, obtaining access is straightforward. Developers can explore its multimodal processing power via platforms like Kimi.com, Kimi.com, API interfaces, and tools like the Kimi app and Kimi code. The model supports various operational modes, including instant, thinking, agent, and the beta release of Agent Swarm, which provides flexibility and adaptability in how tasks are structured and managed. While Kimi K2.5 shows great potential, real-world effectiveness and robustness remain subjects of further examination. Its actual application across diverse industries and inputs hasn't been exhaustively validated, and user feedback will be crucial in refining its capabilities over time. Internal benchmarking suggests impressive efficiency, yet real-world testing will ultimately define the true extent of its power. Kimi K2.5 represents a notable leap forward in the arena of multimodal AI technology, offering sophisticated tools capable of refining and elevating enterprise workflows. It lays the groundwork for future development in multimodal AI applications, potentially inspiring other AI endeavors to adopt similar innovations. As this technology evolves, it may herald a new era in how AI integrates multifaceted data types, fostering progress across numerous sectors. A novel algorithm named Sequential attention promises to significantly improve the efficiency of large-scale machine learning models by optimizing feature selection. Developed by Taisuke Yasuda and colleagues, This method utilizes attention weights to prioritize important features, thereby streamlining the selection process while maintaining model accuracy. This approach addresses a common challenge in the field of AI, where balancing efficiency and accuracy often poses significant hurdles. Sequential attention employs a one-pass, greedy forward selection strategy, which integrates concepts from orthogonal matching pursuit, OMP. This adaptation is crucial because it retains the theoretical guarantees typically associated with OMP in linear regression contexts, allowing for reliable feature selection. The method stands out for systematically evaluating feature contributions, offering a cutting-edge alternative to traditional methods like L1 regularization. Unlike these older methods, which often consider all features simultaneously and aggressively, sequential attention focuses on assessing the marginal contributions of individual features based on attention weights. Technical insights into the algorithm reveal that its one-pass greedy forward selection technique is designed to handle the extensive datasets common in modern AI applications efficiently. By minimizing unnecessary computations, it reduces computational overhead, which can lead to decreased training times and costs, a critical advantage, particularly for smaller organizations with limited resources. The potential applications of sequential attention are vast. In healthcare, for example, models can become more interpretable and focused on significant predictors of disease, enhancing diagnostic processes. In finance, it can streamline the detection of fraudulent activities by focusing on relevant transaction features, thereby optimizing real-time decision-making processes. Despite its promising nature, the algorithm still faces several challenges. Its performance across diverse domains remains largely untapped, necessitating further empirical testing. Moreover, the stability and scalability of the algorithm in dynamic real-world applications are yet to be definitively demonstrated. Comprehensive studies comparing this method with current standards like OMP and L1 regularization are needed to fully substantiate claims of improved efficiency. For those interested in exploring this innovative approach further, the detailed methodology is available in the paper on http://arxiv.org/2209.14888 OpenAI, and insights into its practical implications can be found on the Google Research blog. These resources provide a deeper understanding of how sequential attention can potentially redefine the landscape of AI, offering improved paths towards leaner, faster models without sacrificing accuracy. Ultimately, as further research and applications unfold, this algorithm could become a cornerstone in the next generation of AI model training, offering robust solutions to complex machine learning challenges. Introducing the OSMF, One Size, Many Fits framework, an AI-generated solution aimed at revolutionizing targeted advertising by balancing precision marketing with privacy compliance. This cutting-edge framework works by dynamically segmenting users based on demographics, product interaction, and behavioral patterns using the innovative group-aware multimodal large language model, GMLLM. This advanced model generates highly tailored advertising images aligned with user preferences by incorporating a fine-tuning method known as Group DPO. The scale at which OSMF operates is remarkable. It takes advantage of the Grouped Advertising Image Preference dataset, GAI, which consists of around 600,000 unique groups derived from a massive pool of 40 million users. This dataset enables the framework to achieve superior performance metrics in both online interactions and controlled offline environments, reflecting a new benchmark in advertising technology. In a landscape increasingly overshadowed by privacy concerns, the framework's capabilities align with the Interactive Advertising Bureau's AI Transparency and Disclosure Framework. This alignment demonstrates a rigorous commitment to privacy standards, pushing for more transparent practices in AI-generated advertising. Released in January 2026, this IAB framework sets new industry expectations, effectively encouraging advertisers to shift towards more ethical data usage. However, the deployment of OSMF is not without its limitations and challenges. One significant issue is the ambiguity surrounding the definitions of demographic group characteristics, which could potentially undermine targeting precision. Questions about privacy measure effectiveness in real-world scenarios also loom large, necessitating a cautious approach to implementation and ongoing evaluation. For practice-driven advertisers seeking to delve deeper, the OSMF paper on rxe/ive.org/602-02 OpenAI provides extensive methodological insights. Additionally, the IAB framework offers concrete guidelines for integrating privacy-focused elements into advertising strategies, thus assuring responsible AI usage. Despite challenges, OSMF is poised to play a pivotal role in reshaping modern advertising strategies. By marrying advanced AI capabilities with a privacy-first approach, it promises not only enhanced effectiveness, but also a new level of consumer trust. This positions OSMF as an essential tool for any business aiming to engage their audience in a manner that respects both personalization and privacy expectations, setting a potentially transformative precedent for the advertising industry as a whole. Craft, introduced on December 23, 2025, is a transformative framework that significantly enhances text-to-image generation and editing techniques by incorporating structured reasoning. This innovative approach eliminates the need for retraining models, offering flexibility and efficiency. Craft operates by decomposing user prompts into structured visual questions and verifying the generated outputs using a sophisticated vision language model, VLM. This process allows for refining prompts, improving compositional accuracy, and text rendering, all while maintaining minimal inference time overhead. Unlike previous methods that relied on implicit critiques, Craft's structured reasoning offers a clearer, more interpretable path to high-quality results. This framework is particularly beneficial for models such as FluxSnell, FluxDev, QuenImage, and ZImage Turbo, which can generate images of exceptional quality with reduced computational demands. Evaluations have shown that typically, performance improvements become evident after approximately 3 iterations of prompt refinement. This makes it viable for even smaller, less expensive models to produce images that rival those generated by more resource-intensive frameworks. Craft's ability to improve image quality was rigorously evaluated using the DSG-1K dataset, comprising over 1,000 compositional prompts. This dataset was instrumental in demonstrating Craft's enhanced compositional accuracy and consistency, as human evaluators consistently preferred images generated by Craft over alternative methods. By utilizing newly introduced metrics like visual question answering, DVQ, and auto side-by-side, auto SXS comparisons, Craft not only sets benchmarks for accuracy, but also for user satisfaction and reliability. Developers can integrate Craft into existing text-to-image generation systems, gaining valuable insights and improvements. This can be actionable by evaluating results on datasets such as DSG-1K and integrating its reasoning loop to enhance system performance. Practical implementation details and step-by-step guidance can be found through resources like the Hugging Face blog, aiding developers in optimizing applications. Despite its many advantages, there are specific trade-offs and limitations to consider. While Craft's negligible inference time overhead is generally consistent, its effectiveness and scalability across all text-to-image models require more comprehensive validation. The framework's dependence on structured prompts may limit creativity, and its scalability for large-scale or high-resolution image generation tasks remains largely untested. Moreover, reliance on VLMs for output verification introduces potential biases from training datasets, an area that requires further examination to ensure output quality and fairness. In essence, Craft has the potential to revolutionize the landscape of text-to-image generation. By enhancing reliability and reducing the operational costs associated with high-quality image production, it paves the way for applications in industries ranging from marketing to content creation. Moreover, the possibility of enabling smaller models to deliver results comparable to those of traditionally larger models points toward a decentralization of capabilities, ultimately transforming both industry standards and consumer applications. That wraps up today's episode of the Daily AI Brief. We've explored a range of exciting developments in AI, from Google's adaptive interfaces to NVIDIA's cutting-edge multimodal models. Stay curious, keep coding, and join us next time as we uncover more transformative AI innovations.